Hey guys, in this video we're going to be talking about writing inequalities in two variables. More specifically on how to recognize slope and y-intercept from tables, graphs, and inequalities in two variables. So we're going to start with a graph. Now the first thing you should notice when you look at this graph is that not only do we have a line on the graph that represents our situation, but there's a shaded region as well. That's because when it comes to an inequality, you have more than just the points on the line that can be solutions. In fact, the only time you can have a point on a line be a solution is if that line is solid. If the line is dashed, that means the points on the line are not solutions. But everything in the shaded region always counts, with the exception of anything in the negative section. When I create these graphs, Desmos doesn't understand that there's context attached to the inequality. So it just graphs it as if it's just an inequality. So you need to understand that the only parts that matter to us are between the axes and the line. Nothing in the negatives will count for our situation. All right, so here is the context. It says Dominique can spend up to $20 to provide the dance squad with drinks after their practice. Bottles of water are 80 cents each, and bottles of sports drinks are $1.25 each. The graph to the right represents the situation. Let X represent the number of bottles of water that Dominique buys, and Y represent the number of bottles of sports drinks that she buys. Use the graph to answer the following questions. All right, what is the slope of the line? Okay, in order to find the slope, we first have to have two good points. Now, the first ones that I notice are the y-intercept and the x-intercept. I know that those are two good points, so I'm going to use those. Now remember, slope is rise over run. In this case, we're not really rising, we're going down, so that means my slope's going to be negative. So it goes down 16 and then over 25. So negative 16 over 25 is going to be my slope. That does not simplify, but you could find the decimal version if you really want to. It's negative 0.64. That would be the slope. Now we already found the y-intercept. It's this point right here, which is 16. So number 2 is 16. And then number 3, I want you to find two combinations of water and sports drinks that Dominique could buy and stay within her budget. So again, anything in this shaded region will work and anything on the line. So I'm gonna go ahead and I'm gonna pick this point right here. So that would mean she could buy 3 bottles of water and 7 sports drinks. So I'm going to write 3 bottles of water and 7 sports drinks. Okay, another option could be this point right here. That's 10 waters and 5 sports drinks. So 10 waters and 5 sports drinks. And again, there are many, many other options. Those are just 2 points that I found. All right, let's take a look at an inequality. The freshman class is hosting a fashion show to raise money. It costs $700 to rent the banquet hall they're going to use for the show. They plan to charge $15 for each ticket to attend the event, and they want to raise at least $1,000. The inequality, 15x minus 700 is greater than or equal to 1,000, represents this situation. Let X represent the number of tickets sold, and Y be the inequality. And you're going to answer these 4 questions. What's the slope, and what does it represent? What's the y-intercept, and what does it represent? Now, in order to do this problem, you need to understand that 1,000 is actually put in place of Y. So this is still 15x minus 700 is greater than or equal to Y, where Y is the total profit that the freshman class makes. You need to understand that in order to be able to answer the questions. Now, it's a lot like an equation. The number in front of X when Y is by itself is always your slope. So for problem number 1, my slope is 15. And all that means is each ticket they sell, so each ticket costs $15. That's what the slope means. Then number 3, the y-intercept is negative 700, And it's negative because they had to pay that money for the banquet hall before they even started making any money. So it costs $700 for the banquet hall in order to have the show. And that's it. That would be the whole thing. All right, let's take a look at a table. Last part. All right, so Ms. Green is purchasing school supplies for the upcoming school year. The two most important supplies that she needs to buy are pencils and expo markers. Each box of markers costs, each box of pencils costs $5 and each box of expo markers costs $10. Ms. Green only has $100 to spend on supplies. The table to the right shows the possible number of boxes of pencils, which is X, and the possible number of expo markers, which is Y, that Ms. Green can buy. Use the table to find the slope, the y-intercept, the max number of pencils I can buy, and the max number of expo markers Ms. Green could buy. All right, so to find the slope from a table, remember that you need to find the rise over run, or the change in y over change in x. So when I look at the change in y, I notice that it goes down 1 every time I go down the table, and the x changes by adding 2 each time I go down the table, which means my slope is -1 over 2, or -1/2. Now the y-intercept, remember, is whatever y is when x is 0. So to go from this 2 to this 0, I'd need to subtract 2, which is the opposite as going down the table. So then when I go up the table on the y, I need to add 1, which would give me 10, which means my y-intercept is 10, which conveniently is also the maximum number of expo markers I can buy. So problem number 4, the answer is 10 boxes. Now, to find the maximum number of pencils I can buy, you can do one of two things. You could continue the table by using its pattern, or you can think about, all right, Miss Green has $100. Each box of pencils is $5. So how many boxes could she buy? 100 divided by 5 is 20. So that means Miss Green can buy 20 boxes of pencils with her $100. And that's it. That's how you use slope and y-intercept when it comes to inequalities.